So yeah, so but I'm not able to see anything on the screen. One second. Okay.
You're not able to see on the screen?
Yeah, the participants usually they are visible. Here it's coming on the side.
No, they are there. They are there.
They
All
are
of you
there,
are
no?
able to see, able to hear Manish?
Yes, sir.
Ah, I think they are able to hear you.
Okay, okay.
Okay.
So 16 participants on board.
Correct, correct, correct. Same, same, same. Yeah.
Okay, 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 fine. All right. So let me start sharing the screen. Just give me a minute, children. Everything is ready.
Okay, children, my students, I want to say this class is meant for 12th standard, but we encourage the 11th standard students also to attend, even though they may not understand fully. At least once you sit in this class, after that you go and sit in your class in the school, you will understand there it better. So some exposure, at least some of the words you will be familiarized here for 11th standard. But 12th standard students, it's pakka. They will understand whatever we have to know. They have already gone through the entire 11th. Go ahead with Manish.
Yeah, yeah, yes. So good evening, children. Once again, it's really glad to be associated with Igniting Young Minds. So this is our next lecture for the new academic year. So let me share the screen. Just confirm, children, if you're able to see it clearly. So I'm going to share it. Yeah, the screen is now being shared. Just let me know if you're able to see it, children, now. I've started screen sharing. There might be a small delay, but you should be able to see it in some time. Hope it's visible.
Yeah, it is on the way.
Yes, sir.
I think it is on the way. It will come.
Yeah, there might be a small delay because it takes some 3 to 4 seconds to load at your end. But for me, it's showing that it is being shared right now. Okay, once you confirm, you can quickly start. Yeah, you're able to see the black screen now. It's a black board which I used to explain all the concepts.
No, Manish, so far we have not, it has not come.
Okay, okay. Let me reshare it. Yeah, I'm resharing it now. Yeah, it says that it is being presented.
1 minute, yeah. Yes, it has come.
Yes.
Yes, it
Yeah.
has come.
Okay. Great. So yeah. So we'll continue from where we started, children, in the last class. It's a continuation to the previous lecture. The topic that we had was force. That is laws of motion. It's related to the force. So laws of motion is what we were doing. I'm writing, children. Please confirm if you're able to see what I'm writing. Okay. Laws of motion. I'm writing that. I hope it's visible to everybody.
Yes, sir.
Okay, yeah, you might be able to see it in some time, but it should be visible because there is no delay now. The network speed is also quite fast. Okay, so now moving on. Today, in our lecture, we are going to now look at certain important concepts in laws of motion, which will be very helpful for solving numericals. Okay, for Neet point of view. So now we look at those concepts, and then we'll see. Then we'll look at different questions. Okay, one by one we'll solve. We'll see the concepts first. Okay, anywhere you're stuck, somewhere you feel that it needs to be explained again, please feel free to ask. Okay, please don't hesitate. That is what I'm telling the questions from telling you from quite long. So whatever it is, you can ask, even however simple your doubt might be, don't hesitate to ask. Okay, on that note, so we will start off with the concepts. So here comes the first concept. Okay, when you have objects which are placed, so I am placing an object, children. So these are different cases which you need to understand and analyze. The first one is an object placed on horizontal surface. Okay, object placed on a horizontal surface. That's it. This is the first case. Now, what do I mean by an object placed on a horizontal surface? Now, we have a plane horizontal surface. We generally represent horizontal surface like this. Okay? and I'm going to place an object here. Say I am placing a block, a wooden block. Is it clear? The block is having a mass m. M is the mass of the block. We are just placing it. Now, what do you understand from this? You have an object which is basically at rest. Is the object is in motion? It's not moving, right? It is just placed on the horizontal surface. Now, having this information, we need to analyze and understand what are the forces that are acting on the object. Who can tell me what is the force that will act with respect to the object being placed on the surface? Anybody would like to take a guess?
Frictional force, sir.
Frictional force, yes, there might be a force of friction. Now, frictional force will always act. It's a contact force. I hope you guys will be having an idea about it. So that is a force which will come into picture, when you move the object. If I'm going to move the object towards the left, the frictional force will act towards the right, and vice versa. Okay, so frictional force, yes. Okay, but now you don't have frictional force because I'm not moving the object. So, we don't really account frictional force as of now. Okay, so therefore there is no frictional force as of now because I'm not moving the object. It is just kept on the horizontal surface. Apart from that, can you think of any other forces? But that's a good one. Apart from that,
Gravitational force and normal force.
yeah, very good. Now you're going to have gravity that is going to pull the object downwards, isn't it? So you have weight that is going to act vertically downwards. You know the formula of weight is mass times acceleration due to gravity. So you can say mg is going to act vertically downwards. Is that clear, children? Now to compensate this, you all know that from Newton's third law, every action has equal and opposite reaction. You agree with that? So therefore, there is going to be a reaction force that will act vertically upward, and we call that as normal reaction. Okay, it's called normal reaction. So that will act vertically upwards. Is that clear, children? So these are the forces that come into picture when you have an object placed on the horizontal surface. Now for this, what we do typically is we draw something called as a free body diagram. So here we have something called a free body diagram, which is called FBD. FBD stands for free body diagram. Okay. So therefore, we analyze this block and we are going to show all the objects, all the forces that act with respect to the block. So I'm taking the object here. Here my object is the block. Now with respect to the block, I'm going to show all the forces that act. So I will take the center of the block. With respect to that, what is acting vertically downwards? Weight. So weight mg is going to act vertically downwards. To balance it, you also have a normal reaction that is going to act vertically upwards. Is that clear, children? So this is how you will show the forces with respect to a free body diagram. You just draw the object or the body and show all the forces that are acting with respect to its center. Okay. So now the object is not in motion, it is at rest. So what does this literally mean? The total forces will be equal to 0. Now the net force is equal to 0. Do you agree with me? Are the net forces equal to 0? Yes. Why it is going to be equal to 0? Because the object is not in motion, it is at rest, and all the forces will cancel out each other. Then the normal force and the weight component which is acting downwards, they cancel out and it becomes equal to 0. And that's the reason the object is at rest. Okay, so when I substitute the value here, you need to understand F net. What are the forces acting? The first force is the normal reaction. How is the normal reaction acting? It is acting vertically upward. So we write plus m. You can see weight is acting vertically downwards. We use a sign convention. So I write minus mg is equal to 0. So net force is equal to 0. If net force is 0, you need to understand that normal reaction is equal to mass times acceleration due to gravity. So n is equal to mg here. Both are equal, and that's the reason it is getting balanced, and therefore the object is remaining at rest. Okay, so that is the concept needs to be understood here. When an object is placed on the horizontal surface, the net forces are 0. How it is 0? You can see that normal reaction acting upwards, so it is plus n, and the weight component is acting downwards, so minus mg is equal to 0. So normal reaction is equal to mg. Now there is a simple question for all of you to try and tell me what is the answer. Who can tell me what is the normal reaction acting on a 8 kg block? kept on the horizontal surface? What is the answer? What is the normal reaction force acting on the 8 kg block kept on the horizontal force? What is the answer for this?
8 into 9.8, sir.
Yes, N is equal to mg because it is balanced and the value of mass is 8 and acceleration due to gravity is 9.86. And what is your answer? You just need to multiply them.
Around 78 point something.
Okay,
78.5, I guess.
okay, yeah. So you will get 78 point, I think it should be 8 because it is ending with 6. So 48, right? So 78.8. Okay, 78.8. What is the unit of normal reaction? We say it is a force. So the unit should be in terms of Newton. So it is Newtons. Is that clear? So the normal reaction is 78.8 Newtons. And that is your answer. Okay, so we have, I hope the first case is clear to all of you. When an object is placed on the horizontal surface, how to find out the, how to analyze the forces and then find out the normal reaction that is acting. Second case. Now let's move on to the second case without any further delay. So here we go to the second case. Second case is an object, okay, an object placed on the horizontal floor, okay, on the horizontal surface, on the horizontal surface and pushed with an external unbalanced force, F. This is the second case, the second scenario, where you have an object placed on the horizontal surface and it is being pushed by an external unbalanced force. Let us try to depict this now. This is my horizontal surface. Okay, there is a horizontal surface that I'm drawing. And what do we have? We have an object that is placed like this. And what are we doing? We are pushing this object by applying a force. So there is a force F that is applied and the object is being pushed. Now, what happens? What are the other forces that are going to act? Anybody? When you push it,
Frictional force, sir.
exactly, you will have a frictional force that acts in the opposite direction of motion between the block and the surface in contact. So there is frictional force. We represent frictional force using a small f. Okay, so this is frictional force. So there is frictional force that is acting in the opposite direction to the applied force. That is there. So these are the forces that act along the horizontal plane. Who can tell me what are the forces that act in the vertical plane?
Normal and gravity, sir.
Yes, you have normal reaction and you also have the weight that is going to act, which is m times g. So what will be the free body diagram for this? How will it look? Now let us try it. So the free body diagram, I am going to draw the block. Yes, I have drawn it. With respect to the center of the block, I am going to show all the forces that are going to act. Now, what is the force that is acting, towards the right? It is the applied force. So I will say capital F. This is applied force. Now, opposite to your applied force, I hope you guys are clear. That was a frictional force that was acting. So you can represent it using small f. And vertically upwards, you have the normal reaction, which is N. And vertically downward, you have the weight component due to gravity, that is m into g. Is this clear? So these are all the forces that are going to act, and we have now depicted the free body diagram for the given case. This is how you depict it. Now let's write the reactions, children. Now this object is in motion or not? Is the object in motion?
Yes, sir.
Exactly. In which direction is it going to move?
In the direction of S.
Yes. So towards the right, it is going to move. So you mean to say the object is going to be in acceleration? Yeah?
Yes, sir.
Yes, exactly. It is going to be in acceleration. The acceleration is also a vector quantity. I hope you guys are aware Acceleration can be positive, negative, or zero. It has both magnitude as well as direction associated. So I am showing A is acting towards the right. And how do I know that? Because I am applying force towards the right and it is going to move towards the right. So acceleration will definitely be towards the right. Okay. Now let's see how to write the equations. First equation, I will write it along the horizontal plane. So in the horizontal plane. So in the horizontal plane, now let us see what are the forces that are acting. First, let me write the net force, F net. Now, net force is equal to, now can I say net force is equal to 0? Is it possible to be 0
No.
here? No. Why? Because in horizontal plane, the object is in motion. The forces are not balanced. If it would have been balanced, you can put is equal to 0. But now it's not balanced. Okay. So let me take the block having some mass m kilograms, where m is the mass of the block. Okay. M is, I'm writing here on the top, mass of the block. Now, net. Who knows the second law of motion? I hope you guys know. From the second law of motion, force is equal to mass times acceleration, right? F is equal to m into a. So I can write F net is equal to mass of the block m into acceleration of the block. This time, how is the block moving? It is moving towards the right. So I can write plus a. Is that clear? So m into a. Now, what are the net forces along the horizontal plane? Who can tell me? F is applied towards the right. So, what is the sign convention for that? I will write plus, it is plus F. At the same time as you're pushing, friction acts along the left side. So, what is the sign convention? F
Minus small f.
minus F is equal to M into A. Is this clear, children? So, we understood that the applied force is towards the right, so plus F minus small f, because friction is acting along the negative, along the opposite direction towards the left, so negative sign convention is equal to m into a. Now can we find out what is the acceleration of the block, system of block? So you keep acceleration on one side, shift all other terms to the other side. So what will be the answer? A is equal to applied force minus frictional force, the whole divided by m. Is it clear? This is how you can find out the acceleration of the block. So A is the acceleration of the block. Okay, you can find out the acceleration of the block. Can we also write the equation for the friction? Who can tell me what will be the equation for the frictional force? If they ask you to find frictional force, what will be the equation for that? F is equal to, make F the subject. So what happens? F equals applied force F minus m into a. Are you getting it? So that is the frictional force. Okay. So this is the expression for frictional force. Simple. So like this, when the object is going to be placed on the surface and pushed with a force F, this is how the equations you will get. Okay. I hope this part is clear to all of you. Okay. Now we are moving on. Now I'm doing a slight change. I just want to know if you guys are able to think properly and answer. If you are doing it in the right way. Again, I am taking the same case, children. This time I am applying force from the left, like this. And again, there is going to be a frictional force. Now, who can tell me what is the acceleration of the system of this block? If the mass of the block is m, what is the equation for acceleration? What will you do? First, write down the expression. Okay, frictional force now will act along this direction, like this, right? Who can tell me the equation now?
Minus f plus small f by m.
Yeah. Okay. Now the acceleration will be towards the left, right? Here, like this. Acceleration will take place in this direction. So now you use the formula F net is equal to mass times acceleration. Using this relation we are going to do. But here, what is the value of acceleration? What is the magnitude? Magnitude is A. What is the direction? It's towards the left. So I will write minus sign for this. So it becomes minus m into A. But what is the net force, children? You know that friction is acting towards the right. So it is positive plus F minus capital F is equal to minus m into A. Okay, this is what happens. And who can tell me what will be the expression for applied force? So make applied force the subject. So F is equal to frictional force plus m times a. Is it clear? So you get applied force is equal to frictional force plus m into a. That is what happens here. But here, do you get the difference? Here we wrote F minus ma, and here we got F. I mean, here we got the expression as F plus ma. So appropriately, here also it's F plus ma. If you see, if I rearrange this, what happens? Are you getting? Cap left is equal to F plus ma. So you will get it like this. That's it. So the applied force is equal to frictional force plus mass times acceleration. So that is what you ultimately get, irrespective of which direction the force is being applied. So appropriately you get it. In this particular direction, we get it. Okay. Yeah, I hope I'm audible now. There was some disturbance. Yeah. So is it clear? So this is how you write the expression for applied force. Same way for acceleration also, if you're going to do, what happens the expression for acceleration? See here. So make A the subject, go for a rearrangement. It's capital F minus small f divided by n. Okay. So that is the expression for acceleration. Right? So previously you got the same expression. So depends based on the case how the force is being applied, irrespective of how the force is going to be applied. Ultimately, when you apply sign conventions and when you simplify, you will get the expressions for applied force and acceleration in this particular way. Okay, same way frictional force also. Again, for frictional force, you make frictional force F as a subject. So F is equal to applied force minus m into a. That is the expression for frictional force. Okay, that is also exactly the same way we are getting it. Fine. So this is how you apply the laws of motion. That is, you are applying second law of motion, F is equal to mass times acceleration in the horizontal plane, and you are able to find out what are the values of acceleration, friction, and applied force. We are getting the relations basically, okay, between the physical quantities. Now let's solve a question, children, based on this. A quick question, and I want the answers from your end. So try it out and tell me the answer. This is a question. I'm having a block of mass 6 kg. I'm applying a force of I'm applying a force of 20 newtons. Okay, and the frictional force is going to be 5 newtons. Who can tell me what is the value of acceleration for this given system? Frictional force 5 newtons, applied force 20 newtons. What is the acceleration of the system? Yeah, how do you do it? So you apply the laws of motion and you try to find it out. Frictional force will act in the opposite direction like this, right? It acts in this particular direction, in the opposite direction. Frictional force will
Sir,
act. Yes.
so acceleration is going to be 20
Hmm.
minus 5 by 6, which gives us 2.5.
Hmm. Okay, we'll see. Now, if you want to write down the equation, what will happen? You can see that 20 newtons is acting towards the right. So I will write 20 minus frictional force is 5. So minus 5 is equal to mass into acceleration. Acceleration will take place in the right side, so positive sign. So is equal to 6 into a. Are you understanding how I framed this expression? Based on the force, net force, I know 20 is towards the right, so plus 20. Frictional force towards the left, so minus 5 is equal to m into a. M is 6 and a is your acceleration. It's positive because it's towards the right. So solve this, children. 20 minus 5 is 15. So 15 is equal to 6a, and the value of a is 15 upon 6, which is 5 upon
2, sir.
5 upon 2, right? With 3 table you cancel. 3 5s are, 3 2s are. So 5 upon 2, which is 2.5 meters per second square. So that's the answer. So acceleration A is equal to 2.5 meters per second square. That's the value of acceleration. Okay, as simple as this. So this is how you can solve questions based on this particular case. We have just taken a simple one. Let's now move on to the next case, case number 3. Okay, moving on to the next case, third case. Okay, an object, an object hung from the ceiling, an object hung from the ceiling using a rope. An object hangs from the ceiling using a rope. What do you mean by this? There is a ceiling, so this is the roof or the ceiling you can consider, and you have a rope, and to that rope you have an object that is being tied. It's like this basically. The mass of the object is m kilograms. Now, who can tell me what is the force acting with respect to this particular block? What are the forces which will act? It's basically hanging. So,
One tensional force and another one is
yeah,
mg.
correct. So along the rope, there is a force that will act. We don't call it normal reaction. This time we give it a different name. It's called as the tension force. Okay, it's called the tension force. Any force acting along the strings or the ropes, we call them as tension. And at the bottom, you have weight, which is mass times gravity, that will act. That's it. So only along the vertical plane, you have the forces acting. Along the horizontal plane, you don't have any force as such. Okay. So here, what is the value of tension? When it's simply hanging, so the tension will be equal to the weight, which is m into g. That's it. So directly you can write down the expression for tension as m into g. Because it is balanced, it is in equilibrium. Okay, so the net forces are zero. That's the reason it's able to hang. Okay, so this is how you express it and you find out. There is no acceleration, so here you say acceleration A is equal to 0. There is no acceleration in this particular system. Fine. That is the third case. Now let's move on to the fourth case. Okay. Fourth case. An object tied to the rope and pulled using a force F. An object tied to the rope and pulled using a force as shown. Okay, an object that is tied to the rope and we are pulling it using a force. Let us visualize this. So again, you have the ceiling like this. Okay, and pulled using a force. So from the ceiling, I'll make it more clear because you need to understand where it is. Pulled using a force. From the ceiling as shown. From the ceiling. So here we will see again you have the ceiling here on the top. Okay. Now this time, initially if I see, the block would have been like this. I'm using a dotted line so that to show that initially it was hanging like this. For the previous case. Okay. Now what we are doing, we are pulling this by some force so that its position now is here. This is the final position. This is the actual position now after we are applying some force. So we are applying a force like this and we are pulling it. So what do you think is happening? With respect to the original position, there is an angle theta that it makes. Okay. So, and you know that here, what is the force that acts along the rope? I hope you guys are aware about that. So the force that is going to act along strings or ropes is going to be the tension force. With respect to the block, what are the forces that are acting? On the left side, the force that you are applying to hold it in place. And at the bottom, you have mass times acceleration due to gravity. The weight component will act. Having all these things, you have to understand, you have to now find out what are the system of forces. Okay. So here, tension is acting in this particular direction at an angle theta. So now what I'm doing, I am going to extend in the vertical plane and identify where is that theta coming into picture with respect to the block. So if this is theta, Don't you think this is also going to be theta? Right? Because alternate interior angles are equal. It's like alternate interior angles. The line, the angles where you have a transversal in between. Two parallel lines cut by transversal. So here alternate interior angles are equal. So this angle is also going to be theta. If this angle is theta, now what we do, we are going to write down the vertical and horizontal components of this row. So what are the vertical components and what are the horizontal components? Let us see. So let's draw the free body diagram for this. So we have it like this. With respect to the center, I'll show it. So here, this is the actual row where the tension T is acting. Okay. So, and along the vertical plane, I'm just using a dotted line. So this angle is theta. And towards the left, you have force F that is acting. At the bottom, you have weight, which is M into G that is acting. Okay. This is the given scenario. This is the scenario. So you show everything. Now, you can see that tension is acting at an angle, but we want only along the vertical plane or on the horizontal plane, like this. We want to find out these values. So what is the vertical plane? If tension is making an angle of theta, like in this particular direction, in the vertical plane, it is called as T cos theta. This is called resolution of vectors. We are resolving this vector in the vertical plane. Is that clear? And how did I get T cos theta? Anybody, any idea? So if you see, it will form a right angle triangle like this. If I draw a vertical line from that point along this axis, it forms a right angle triangle. So if this is theta, this is 90 degrees. Then you can see that this particular length, okay, I'll just name it. I'll take this point as O, I'll take this point as A, and this point as B. You can see OAB is right angled at A. Okay, and what is AO with respect to the trigonometry? You know that this is theta, this angle is theta. Okay, this angle is theta. So you can see that it forms a right angle triangle. You're able to visualize. It is like this. This is theta and this is 90 degrees. So can't you find out this particular ratio? If this is A, this is B, and this, okay, this is O I have taken, this I have taken it as B. Okay, fine. This one we will keep it as O. Okay, as per the figure. So what is cos theta in this particular figure? You all know that cos theta is trigonometric ratio which relates adjacent side and hypotenuse, right? So what is the adjacent side for theta? It is AO upon hypotenuse. Here, with respect to the hypotenuse, it's going to be OB, right? OB is nothing but T, which is your tension. Okay, so AO upon T. So what is AO? You can see AO is T cos theta, and that's how it came. Is it clear? So the vertical component is T cos theta. And what will be the horizontal component? It will be T sin theta. Cos of 90 minus theta, you will. Okay, so you will get T sin theta. That's how you're able to, that's how you should visualize. Okay, so I'll again show it here. You need not worry, because this is based on vectors, resolution of vector. So I'll just show it here. So this is a vertical component. Okay, this is actually the x-axis and this is the y-axis. I'm using a dotted line convention because I used a dotted line convention there. Okay, and here our tension was acting like this. All right. Now this is basically your y-axis and this is your x-axis. Okay. Now T is making an angle of theta. Here for our question, it was making an angle theta with the y-axis. So what did we do? We are actually dropping a perpendicular from T to this point. That is what we are doing. Okay, this is origin. This point we take it as A. This point we took it as B. So we are actually finding out this length AO. So AO, if you're using Pythagorean theorem, and when you're solving it, OB is actually equal to T. This is anyways T. That is a T, is the tension component. That is a force, that is a value. So don't you think cos theta is equal to adjacent, which is AO, upon hypotenuse, which is T. And you simplify, you will get AO is equal to T cos theta. And what about on the x direction? Along the x plane, what is the component? Again, I will drop another perpendicular, okay, and I'm going to mark another point, say C. In triangle OPC, what about this angle now? Who can tell me what is this angle? If this angle is theta, don't you think this is 90 minus theta? Agreed? So therefore, OC will be equal to the same logic you will use, and you will write T cos of 90 minus theta. What is cos of 90 minus theta? Cos of,
Sine.
exactly, it is sine theta. So you can write OC is equal to T sine theta. That's how you write it. Okay. So basically we are resolving the vectors in the horizontal and in the vertical plane. That's what we are doing. Okay. For the above situation, that's what we did actually. Okay. So I'll again show you the diagram. Let's now again look at the diagram again. So when the block is being tied to the ceiling, and then the free body diagram we are trying to represent. So imagine this is your block, and our tension force was acting like this. And what was the angle made by this tension force along the vertical plane? The angle made was theta, right? So this angle was theta. And now we are writing its component. This component along the vertical plane, T cos theta, and along the horizontal plane, it is going to be T sine theta. I hope you guys remember, towards the left there was one force that we applied, which is F. And at the bottom, weight is going to act, which is M into G. So these are all the forces that comes into picture for this case. Now, I want you guys to tell me what are the forces that act in the vertical plane. In vertical plane, what are the forces? What will you write? In the vertical plane, what are the forces that you're able to see?
Theta.
First, yes, T cos theta. What is the sign? Is it plus or minus? Is going to be
Plus.
positive. Yeah, plus, because it's acting upwards. So T cos theta, you can see weight is acting downwards. So you will take minus M into G is equal to, now mass of the block is M. So force is equal to mass into acceleration. So M into, what about the acceleration, children? In the vertical plane, is the block moving or not?
No, sir.
No, it's not in motion, right? So here it is 0, M into 0. So totally it becomes equal to 0. So you will get T cos theta is equal to M into G. Is it clear? So you can find out the value of tension T as mg upon cos theta, and that's it. Okay, so like that you can find out the value of tension. Okay, that's how we relate the formula. We got the formula. Same way, who can tell me in the horizontal plane what is the expression? Along the horizontal plane, what will you write? Yes, give it a try.
I think it's
Yeah,
T sine theta minus F, sir.
yeah. In horizontal plane, it is T sine theta. Very good. T sine theta is acting towards the right, positive. So you write it first. F is acting towards the left. So minus F is equal to 0 or not? Will it be equal to 0?
I don't think it will be equal to zero.
Okay. Here you are pulling that force. See, you are pulling it and you are holding the block actually there. Are you understanding? You're not pulling it like that, forever. So if you keep on pulling it, it will go, and at a point the rope is going to break. Are you understanding? So it is pulled and it is held at that place. So actually acceleration is not there. Okay. So it is 0. So you will get T sine theta is equal to F. And what do you get here? So basically you get T is equal to F upon sine theta. So that is the value of tension. Okay, simple. So like this you get the relationships. Now you can see your equation 1 and equation 2. Don't you think it is tension? Both of them relate tension, right? Both equation 1 and equation 2 both are tension. Can I equate them? Is it okay to equate? Right? Yes, you can, because both of them deal with tension. So it's equal to T. So equate both. What do you get by equating? You will get mg by cos theta is equal to F upon sine theta. That is what you get. Okay. Now in your exams, they will ask what is the value of tan theta. So how can I bring tan theta? Is it possible to make it in terms of tan?
Yes, sir.
Yes. How can I do it in terms of tan? Just rearrange. So I can write sine divided by cos is equal to, I'm just shifting the sign towards the left, okay, is equal to f upon mg. Okay, sine theta by cos theta is equal to f upon mg. Okay, so that means tan theta is equal to applied force F upon m into g. That's it. Okay, so like this you can find out what is the relation for tan, trigonometric relation. So it's F upon mg, and that's it. Is that clear? This is how you approach such, such cases. If at all you have questions, where an object is tied to the rope and then it is pulled by a force and it is kept with that in that particular place. Of course, the force is acting, but it is, that force is going to be constant. You're not changing the force. Therefore, it is held at that particular position. Okay. So this is how we relate. Is that clear, children? Any doubt so far? Is it clear to all of you?
Yes, sir.
Yes. Now I'll give you a question, and I want you guys to tell me, what is the answer. Okay. So here, I'm giving this is a question. I'm just drawing the figure. So you have an object that is, held from the ceiling. Okay. So this is the block. So block, is basically going to have the mass as say 5 kg. 5 kg is the mass of the block. Okay, and T is the tension. We don't know the value of tension, and there is a force that is going to act in this particular direction. Then the force is equal to 30 newtons. Okay, force is 30 newtons. Fine, and so having this limited data, you will have to calculate what is the angle. What is this angle theta? So you will calculate what is this angle theta. Force is 30 newtons. Mass is 5, kilograms. Okay. So 5 kilograms is the corresponding mass. Okay. I'll do one thing. I'll just change this value. Hang on. So I'll make it as 3 kilograms. Instead of 5, I'm making it as 3 kgs. Okay. So now you will have to calculate what is the angle of theta. You can assume acceleration due to gravity as 10 meters per second square for this question. So who can tell me what is the value of theta in this question? What will you do? You want options like Neet format? I'll give you the options. Option A, 30 degrees. Option B, 60 degrees. Option C, 45 degrees. And option D, 90 degrees. I mean, it's not possible to be 90. Okay, so I'll make it 15. As you can see it's not 90 from the figure. 15 degrees. Which is the correct option? Try it out and tell me what's the answer, children, you're getting.
Option C, 45 degrees, sir.
Option C, 45 is the right answer. Very good. How did you do that?
F equal to mg tan theta.
Yes. Okay. So F is equal to mg tan theta. You can simply say, tan theta is F upon mg. So what is theta? Theta is tan inverse of F upon mg, isn't it? So what is tan inverse of F upon mg? Go and substitute, children. What do you get? You get F is given in the question as 30, right? And mg is 3 into g. G is 10. 3 tens are 30. 30 by 30. You'll get cancelled off, right? So what do you get? Theta is equal to tan inverse of 1. For which value of theta is tan ratio going to be equal to 1? 45, right? So it's 45. The answer is 45 degrees. That's the answer. Is it clear? So this is how you can find out, questions wherein, these are important aspects. So again, see how we got the answer. That is from this relation. So for this relation, you will have to, basically get this expression. You will have to correlate and then bring it. It seems to be simple now because we have derived. But in your exam, when situations are given, you will have to put yourself in that situation, frame the expression, deduce and get the relation, and then you will have to substitute. Okay. So that's how, in that direction, when you think, you will get the answer. Okay. So now we'll move on to the next, case. I'll just look at what is the number. It's 4. We'll look at next case, fifth case. Okay, case number 5. Okay, case number 5. Uh, Say an object tied by two ropes, two ropes, making making angles alpha and beta, tied with two ropes, making angle alpha and beta with the ceiling. With the ceiling. So let's represent it. So children, again we have the ceiling or the roof. Now this time you have one block. There is no doubt about it. There is a block, okay, which is there. But this block is being now tied with the rope, okay, by two ropes. So you're tying it with two ropes like this. Okay, one rope is acting towards the right and tied towards the right, and the other rope is tied to with respect to the left. So I'll put it this way, towards the right, and one more is towards the left. Say like this. Okay, two ropes. And what are these? What are the angles made by the ropes with the ceiling? With the ceiling, it is making an angle of alpha, and the other one is making an angle of beta, like this. Okay, this is the given scenario. Okay, so when this is the given case, now here you know that there is going to be tension that is going to act. I hope you guys know. Let us take for the first rope, the tension is T1. Second rope, the tension is going to be T2. Okay, this is how the ropes are attached. And what is the other force that is acting, children? At the bottom, don't you think there is going to be a weight component that is going to act, right? With respect to the figure. So you have weight also that is going to act vertically downwards, which is m into g. If mass of the block is m, so obviously mg would act vertically downwards. Okay, this is your given case. Now, having this particular case, what are the relations that you can write? Okay, let us see. For this, again, you will simplify this, you will resolve this. So I'm going to draw a vertical line. Yeah, tell me.
Can we apply Lamy's theorem?
Yes, you can apply Lamy's theorem. Good. You can apply Lamy's also. Lamy's rule or Lamy's law can be applied. Yes, you can do that. For that, you need to find out what are the angles that it is going to make. Okay. So therefore, I'm going to draw the vertical and horizontal planes here. So when I do this, children, I understand that the angle here is 90. Okay, because this mg is acting along the negative y direction. So it will make an angle of 90 with the x-axis. That is this dotted line that I have drawn. So what you will have to do is you will have to find out where alpha and beta are formed here with respect to the block. That is what you will have to find. So if this is alpha, don't you think this angle is also going to be alpha? Do you agree with me? Because it's alternate interior angles, right? Same way, if this is beta, this is also going to be beta. Same alternate interior angles concept again. Okay, so that is how you find out what is alpha and beta. So I found out alpha and beta, and here the angle is going to be 90. So one of you said that we can apply Lamy's rule or the Lamy's theorem. Yes, you can apply it, and then you can find out. Now, if this is alpha, who can tell me what is this angle? What is this?
90 minus alpha.
Very good. That's 90 minus alpha because total angle is 90. So this is 90 minus alpha. Same way, this angle is also going to be 90 minus beta, right? So therefore, you draw the free body diagram for this particular block. So I take this block and I'm going to show all the forces that are going to act. The force that is going to act here is say T2. The force acting here was T1 towards the left. So I'm showing T1. The force acting vertically downward was mg. Now I'm going to show all the angles which are there in between. Now what is the angle here in between is what I'm going to show. That is between them. What is the angle between them? 90 minus alpha plus 90 minus beta. So you have to simplify this. 90 plus 90 is 180. So 180 minus of alpha plus beta. So 180 minus of alpha plus beta is what you will get. Okay. That is 180 minus alpha minus beta. You can write it that way also. I have taken the common out and I have written. Okay. 180 minus of alpha plus beta. So that is the angle in between. Now what about this particular angle here? This angle. So again, that is alpha and here 90. So this is 90 plus alpha. The angle on the right side, that is 90 plus theta. That's it. So we have found all the angles and you can see all the forces are also there. Now there is a simple rule called as Lamy's rule or Lamy's theorem, which gives you the relation that T1 upon the angle opposite to T1. What is the angle opposite to T1? 90 plus beta. So T1 divided by sine of 90 plus beta is equal to T2 upon, again, you write sine of the angle opposite to it, which is 90 plus alpha, is also equal to mg is the other force. So mg divided by sine of 180 minus of alpha plus beta. So I'll write fully sine of 180 minus alpha minus beta. I just write it like that. Okay, that's it. This is called Lamy's theorem or Lamy's rule. Whenever you have three forces that are acting and provided you know the angles between all the three forces like this, say the first force is F1, second force is F2 and third force is F3 and the angles are, say this is theta 1, this is theta 2 and this is theta 3. Then using Lamy's theorem, we can simply say F1 upon sine theta 2 is equal to F2 upon sine theta 3 is equal to F3 upon sine theta 1. This rule is called as Lamy's rule or Lamy's theorem. By using this, you can find out the answer, very fast. It's an effective method to calculate the forces. This only applies for concurrent forces. What do I mean by concurrent forces? The forces which act with respect to a common point. Only then you can apply Lamy's rule and you can find out. Okay? So for concurrent forces, you can apply and you can find it. That's how it works. Is that clear, children? So this is how you do it. Okay? That's how Lamy's rule is basically, put to use. Okay? Now let's see a quick question. I want you guys to try and tell me what is the answer. Okay? Here we go. Here's the question. Here is the roof. Okay? Now we are taking a block, children. So here there is a block. Okay? The mass of the block is 50 kg. Now the block is tied to the rope as shown in the figure. Okay? I am tying this block. I'm not showing with respect to the center because I've written the value there. So, I'm just showing it like this. So there are two ropes. Your agenda is to find out what is the tension of the ropes. Tension in the ropes basically. You will find out what is T1 and T2. Okay. I'm giving you the angles, children. This angle is here. I'll just write it. This angle is 30 degrees and this angle is 60 degrees. Your objective is to find out what is the value of T1 and T2. Okay. Yes, proceed, children. Go ahead, do it, solve it, and tell me what's the answer that you're getting. You can use Lamy's rule or the general method I taught you. Okay, choice is yours. Tell me what are the values of T1 and T2. Okay, take your time, solve it, have a notebook, solve it, and then tell me. calculate the value of T1 and T2. You can take acceleration due to gravity as 10 for simplicity. Yeah. Any answers? I hope you guys have drawn the free body diagram for this. Again, show all the forces. Yes, children. Yeah. No idea.
Sir, is the answer is 1000 and 1000 by root 3?
Okay. T1. T1. What is the answer, dear?
1000,
1000. 1000 newtons. Okay. And T2?
1000 by root 3 Newton.
1000 by root. Okay, good. Somebody is right. Very good. We'll see. We'll check if it's right. Okay. Now I'm going to now show you what is the free body diagram. So in free body diagram, what do we do? With respect to the center, we will draw all the forces and we are going to show. So left on the right side you have T2. On the left side you have T1. So T1 is acting like this. And at the bottom, you should not forget the weight will act, right? And I told you take G as 10. So what do you think will be the weight? It will be 50 into 10, which is 500 newtons. So 500 newtons will act at the bottom. Agreed? So these are the forces that are acting. Now, I told you will show the vertical and horizontal, components. So here horizontal line and I'm drawing a vertical line for reference. Okay. So I hope you guys know how to mark the angles. So if this is 30 degrees, I hope you guys would have written this also is 30 and this angle is going to be 60. And in between, this is going to be 90 minus theta. So, whose value will be 90 minus 60, right? So anyways, I can directly find out the value. Here, if you see it forms a triangle, children, you know the angle sum property of triangle, right? 30 plus 60 is 90 and so this also has to be 90 by using angle sum property. So this angle is going to be 90. I am writing it like that directly. Okay. Now, if this is 630 and this is going to be 90 again, and here also it is 90. So now we have identified all the angles. Okay, and once you have identified all the angles, now let us apply the Lami's theorem. By applying Lami's theorem, we will get T1 divided by what is the angle opposite to T1? We have 60 and 90, right? So I will write it as sine of 90 plus 60 is equal to, next T2 I will write. So T2 upon what are the angles opposite to T2? 90 plus 30. So sine of 90 plus 30, which is equal to lastly 500 divided by what is the angle opposite to 500? It is 90, which is sine 90. Is this clear, children? This is how you bring the relation. Now you see what happens. T1 divided by what is sine of 90 plus theta? I hope you guys know the all silver teacups rule. You would have learned it in trigonometry. So what is sine of 90 plus theta? It is cos theta, right? Yeah, so I will write now directly cos 60. This is where most of them go wrong. You will add, and then you will struggle how to find out the value. You should be very careful. You should apply the trigonometry what you have learned. Okay, so sine of 90 plus theta is cos theta. So I will write cos 60 is equal to T2 divided by sine of 90 plus theta. This time it is 30 degrees. So it will be cos 30 degrees is equal to 500 by sine 90. I hope you guys know sine 90 is 1. So it is just 500. That's all. So now what is T1? T1 you just rearrange, children. T1 is equal to 500 into cos 60 degrees. What is the answer now? 500 into what is value of cos 60? You guys know what is cos 60?
1 by 2.
Yeah, it is 1 by 2. Okay, so cos 60 1 by 2. So how much is 500 by 2? 250. So the answer is 250 newtons for T1. Same way, what is T2? Just rearrange 500 into cos of 30 degrees. And how much is that? What is the answer now? 500 into cos 30 is root 3 by 2, right? So the answer will be 250 root 3 newtons. Is it clear? So that is how you get the answer. So T1 is 250 newtons and T2 is 250 root 3 newtons. This is the answers for T1 and T2. Okay, that's how you do it. Okay, so you must be very careful while solving such questions. So properly you have to find out the angles and then apply Lami's theorem carefully. Here we have applied Lami's rule. First, what did we do? We identified what are the angles. Okay, first all the angles we found out, and after that we applied Lami's rule. Then we applied trigonometry, all silver teacups rule, sine of 90 plus theta, 90 minus theta, whatever it is. So substitute sine of 90 plus theta is going to be cos theta, right? So appropriately we applied that and then we found out. Okay, so and then we simplified, rearranged, and then found out what is T1 and T2. Okay, it's very interesting. If you understand the logic, it's very, very simple. Physics is not difficult. It's a subject, which is very easy. You understand, you put yourself there and you think, you get the answers. Okay, so this is how you approach it step by step. This question, is again important. So based on Lami's theorem, you can see how fast we arrive at the answer. It's a very quick method to arrive at the answer. Now, even without using Lami's rule, if you ask, can we find out? Yes, you can find out by without using Lami's theorem. It is very much possible. Okay, how do we do that? Without Lami's rule. Okay, you are going to now resolve it into horizontal and vertical components. Okay, so T1 and T2. Here you can see T2, I resolve it to vertical and horizontal component. So T2 on the vertical component and horizontal component, if you are going to write, T2 is making an angle of 60 degrees with the horizontal axis. So this is T2 cos 60 degrees. Okay, and on the top, it will be T2 sine 60 degrees because cos of 90 minus theta rule, is basically applicable. Okay, so appropriately on the top, it is going to be 90 minus 60. Appropriately you write it. Okay, so this is T2 sine 60 on the top. Same way here also, T1 sine 60 will also act. Okay, I will write the values. T2 sine 60 and T1 will be sine 30 degrees. Okay, not 60 because you can see that angle is 30, right? So T1 sine 30 degrees will act like that. And on the left side, T1's horizontal component will be T1 cos 30 degrees. That will act. So once you have written all the components, it is just simplification. You can see T1 cos 30 and T2 cos 60, they are equal and opposite in direction. Okay, so both of them will be equal. So you will get the equation as T1 cos 30 is equal to T2 cos 60. So that is the first expression that you write in the horizontal plane. So I'll just write it in horizontal plane. T1 cos 30 is equal to T2 cos 60. That's it. Now you go for a simplification. Okay, you know the values of cos 30 and cos 60. How much is that? How much is cos 30? You go and substitute. So you'll get T1 times, what is the value of cos 30? Root 3 upon 2, right? So T1 times root 3 by 2 is equal to T2 times cos 60 is just 1 by 2. Both the sides you can cancel off the 2's. So you can see that T2 is equal to T1 times root 3. This is the first equation we get. Same way, you will get another equation here in the vertical plane. The vertical plane, you can see T1 sine 60 plus T2 sine 60. I mean, both of them you need to add, and you will equate it to 500 units. That's it. Okay, T1 sine 30, T1 sine 30 degrees plus T2 sine 60, right? T2 sine 60 is equal to 500 because it is balancing it. Go and substitute that also. Sine 30, I hope you guys know. Sine 30 value is half. So T1 by 2 plus T2 times root 3 by 2 is equal to 5. Now what I am doing, I want to get rid of this 2 in the denominator. So I can just multiply with 2 on both the sides. So if I multiply with 2 on both the sides, it becomes T1 plus T2 root 3 is equal to, multiplying with 2, so 500 into 2 is 1000. So I will get it like this. Now you simplify. Go by the method of substitution. So I can simply say T1 plus, here in the place of T2 I can put T1 root 3. Not to forget, there is already one root 3 there. So into root 3 is equal to 1000. So T1 plus, here what happens, root 3 into root 3 is 3, right? So 3T1 is equal to 1000. So I will get 4T1 equals 1000. So what is the value of T1? 1000 by 4. How much is 1000 by 4? 250. That's it. So we got T1 as 250. And what is T2? Because you got T1, go and substitute here 250 root 3. And that's the answer. See, don't you think the answers are the same? Previously also we got the same thing, right? T1 is 250, T2 was 250 root 3. Now also we got the same thing, but it's a different approach. Now, in the competitive exam, you will have to use the previous approach. Okay? For your board exams, this is fine. If they ask for 5 marks, you justify on your paper by doing all this. Okay? But for a competitive approach, you don't have time. You have just 1 minute or just less than 1 minute. So you should be very quick in answering. There, Lamy's theorem really gives you a very good aid. It helps you to get the answer very fast. Within seconds, you can find the answer. Okay, but for the examination point of view, your board exam point of view, this is the approach which is needed. Okay, because this question might be valued at 5 marks, so the examiners would require you to solve them and then find out the answer using this method. Okay, so it basically the approach varies based on the type of exam that you're giving, be it board exams or competitive exams. Both have a different approach of answering. Okay. Okay, so there you give more importance to the weightage of marks, and as far as boards are concerned, for competitive exams, everything is just one mark. So you just you should be quick, and you have to be accurate and fast. So for that, this approach is more appropriate. Is that clear? So we have looked at both the approaches. So you can decide. Fine. So but the concept is the same. Okay? The way you resolve it and you simplify it and do it, that's the same approach. Okay. But the way of solving the approach varies. The way of you solve it, that depends. Okay. I hope you understand now how to do it. Okay, that's the reason whenever I'm teaching any concept, then and there when you solve questions, you basically understand, you apply it, and you get it. You get to know how to solve it. Okay, so that's the interesting part. So then and there when you solve it, you're also confident of how you need to approach such questions if they happen to appear in your exams. Okay, so on that note, so now we'll move on to the next one. So there are different actually aspects to it. One more concept and then we'll wind up. Okay, I don't want to take more of your time. Okay, because I was late, I just want to compensate for that. Okay, so we'll just look at one more concept also. Okay, it's not that difficult, it's quite simple, so we'll look at it. So we'll now the concept number, let me just check. Number is 6. Okay, concept number 6, sixth concept. So we'll see what it is and how to approach this. We'll look at it. Okay, two objects tied to a rope. Two objects tied to a rope and pulled with a force. Two objects tied to a rope and pulled with a force along horizontal plane. Okay, along the horizontal plane. Now what do you understand from this? You have two objects, both of them are kept on the horizontal plane as shown in the figure. So here you have the horizontal plane, and I'm taking two objects this time. So this is the first object. Say its mass is m1, and this is the second object. Say its mass is m, and both of them are being tied to a rope. Okay, not to forget that. So both of them are tied to the rope like this, and then they are being pulled. Okay, so they are being pulled like this by applying a force F. Okay, so you are pulling them. When if this is the case, now what happens? What are the equations and how do we write it? Okay, now because the surface and contact is the same for both M1 and M2, the force of friction is going to be same for both of them. So force of friction will act with respect to both of them in the opposite direction like this. Because both of them are tied with a common rope, there is going to be a tension force acting with respect to both the objects, and you call that as T. Okay, and obviously normal reaction and weight will act for both of them in the vertical plane, and they are going to be in the opposite directions. Okay, and they will cancel out each other anyways. So these are the forces which are there prominently. Now we are going to write the equation for this acceleration of the system of the block, because we are pulling it with a force F. Acceleration will act towards the right, like this. Because you're pulling it towards the right, both of them will move together towards the right. Okay, so the acceleration is going to be A. Now, how do you write the expression? The total force, the net force, we are going to write. So F net is equal to mass of the entire system of blocks. Okay, both the blocks, first one is M1 and second one is M2. Okay, so both the blocks, so I will write M total times acceleration of the system of the block is A. What is the net force here? What are the forces that are acting? One is your applied force, agreed, which is F. What is the other force that is acting with respect to the blocks? You have the frictional forces that are acting, right? So it acts in the opposite direction of motion. So minus is equal to, what is the total mass of the system of the blocks? It is m1 plus m2 into acceleration is the represented by A. It is acting towards the right, so positive sign convention. Simple. So we can find out the acceleration of the system of blocks as A is equal to applied force minus frictional force upon m1 plus m2. And this is how you can write the acceleration for the system of blocks which are tied using a rope. Now you see here we don't have tension at all. We have eliminated the value of tension directly because both are tied with respect to the same rope. So directly you can find out the acceleration using this. But if they ask you the tension in the question, then you will have to consider them. You will have to write down the equations for each block M1 and M2 separately to find out the tension. So for M1 you will write separately. For M1 if I am going to write separately, what will be the equation? Tension is going to act along from M1 towards M2. So it is acting towards the right. So T minus frictional force is equal to M1 is going to move towards the right. So M1 into A. You will write like this. Okay. So ultimately T is equal to F plus M1 into A. That is how you get the expression for the first block. Who can tell me the same way for block M2? Can you try it out? What will be the expression, children, for the block M2? This time you will also consider the applied force, isn't it? So applied force is also there. So F minus tension is going to act, it is going to be on the left side. So then F minus T, frictional force is also there, not to forget that. So minus F is equal to M2 into A. So all of them you will consider this time. Okay, so F minus T minus F is equal to M2 into A. That's how you express. Okay, simple. But you know what is tension from the previous expression. We know the value of tension. So therefore, I can simply write F minus F. Frictional force is equal to minus T. I am shifting to the right side, so I will write it as T plus M2 into. Is that clear, children? Now I go and substitute the value of T. What happens if I substitute the value of T? You know that from the previous expression T is equal to F plus M1A. Go and substitute. You will get F minus F is equal to the place of T, frictional force F plus M1 into A plus M2 into A. Take the common outs, okay, and appropriately you are going to express them. So when you try to eliminate them, so try to express them appropriately. Frictional force is going to be common here. So frictional forces will be common, and ultimately you will get the relation. You can take M1 and M2 also. I mean acceleration also as common. So you take that as common and then you express. That's it. Okay, express them and then get the relationship. Okay. So here again you need not represent the friction also separately because you know that friction is going to be common for both of them. So I'm not representing the friction separately for both of them. Okay, that's it. So here simplify. So F is equal to what happens? You shift the frictional force to the right to F plus A times M1 plus M. And you know that acceleration is equal to F minus 2F divided by M1 plus. Now here when you solve the system of blocks individually, you can see that the frictional force is minus 2F, and previously we didn't do that. See, we just wrote F minus F. But because there are two blocks, 2F has to be considered. So we do the correction here. This is called the error correction. We correct the error. Because individually when you do it and when you simplify, that is when you understand that frictional force is 2F. Okay, and not just F. So this is something to be considered in this case. Okay. So that is how you get the expressions for acceleration. That's it. And tension for relation is written here on the top. T is equal to F plus M1 into A. That's it. So that's how you can calculate what is the tension force acting along the rope. Okay. So I know it's already time. So I hope you guys have understood it. Please go through it. Then and there, you will have to practice. So consistent practice is very important. So try this out, tomorrow, whenever you're free, sit, try. I'm anyway sending you the notes. So sit and try it, children. That is when, you will get it. The more you try, the more you're benefited. So please try them out. Any doubts you can revert, you can ask, okay? During the lectures, you can ask and get it clarified. even in WhatsApp also you can post it. Okay, provided I'm free, I'll definitely revert back. Okay, so this is how we do it. Fine. So we have looked at different concepts. Okay, today. So very important competitive point of view. Also, I have solved the questions. So please go through it. Okay, and practice it on a daily basis. You practice, not just before the exams. This I tell it to tell to all the kids. I know you guys would have been you're occupied with other subjects as well. So make a strategic plan, and you have to practice it. Practice all the subjects consistently, so that you don't lose the touch. Okay. So yeah, with that we can wind up for today's lectures. Any doubts you can ask. Okay, now the forum is open for doubt clarification. Yeah, Madhavan is asking some doubt. You have raised your hand. Okay, yeah. What is the doubt? Okay, previously he was there. Okay, now he is not. Okay, welcome, welcome, children.
Thank you, sir.
Yeah, you're welcome.